You're welcome, viewers. Today we are going to be looking at questions under dimension in physics, so that we'll see how WAEC brings their dimension questions and see how we can tackle them. Come and learn with me. This is WAEC 2020 question on dimension. In our previous class, we looked at dimensions of some physical quantities, some fundamental and derived quantities, and we were able to see how we can get dimensions of quantities using their formula or their units. Now we are going to look at a question, the way WAEC prepare question on dimension. This question said the velocity v of a wave in a stretched string depends on the tension T. Now, someone in SS1, because dimension is an SS1 topic under physical quantities and units. So someone in SS1 will say, what is bringing wave here? We've not learnt wave. I don't know what is wave. Now, don't panic. You don't need to know what a wave is. You don't even need to know what most of those terms we are going to use that was used in this question stand for. All you need to know is to know those quantities that have units and have formula so that you'll be able to determine their dimensions, such as velocity. You don't need to know what a wave is. Velocity is velocity, whether it is of a wave, whether it is of a body in motion, whatever it is, velocity remains velocity, and the formula for velocity remains what it is. The unit remains what it is, and of course, the dimension will still be the same, irrespective of what velocity is being referred to. So they said the velocity of a wave in a stretched string depends on the tension T in the string and the mass per unit length. They use this symbol to represent mass per unit length of the spring. Obtain an expression for V in terms of T and mu using the method of dimension. So that symbol mu is used to represent the mass per unit length. So what we are going to do is just to understand those physical quantities and use them to determine the dimension. So what the question said we should do is simply this. The question said that the velocity v, let's itemize the quantities, velocity v and tension T and mass per unit length, mass over length, that is the meaning of per unit length, mass over length is represented with mu. Obtain the relationship, an expression for v in terms of t and u. When they say obtain an expression for v in terms of t and u, it means we should write a formula that contains v, t, and u, where v is the subject of the formula, v, t, and mu. So this is an expression for v, t, and mu, where v is made the subject of the formula. But we do not know the relationship. We do not know whether this is directly proportional to this, or inversely proportional, or directly proportional to the square or square root. That is what they ask us to obtain. So what we are going to do is to determine the relationship between v, t, and mu. That is what the question intends that we do. So we are going to, the steps to take is to, at the right hand side, assign powers to those quantities at the right hand side, since you don't know their relationship, whether v is equal to t raised power 1 or t raised power 2 or t raised power minus 1 or whatever it might be. So our job is to determine the values of x and y. Determine the values of x and y as I have labeled. You can give it any letter. Now there is something I want us to understand. While determining this is velocity. We've done the dimension of velocity. Tension, we've not had tension, but we've done something similar to tension. Now note today, if you have not known before, that tension is equivalent to force. Tension is equivalent to weight. Tension is equivalent to reaction. Tension is equivalent to friction. and some other quantities we can use to replace tension. So when you talk of tension, force, weight, reaction, friction, these quantities have the same unit. They all mean force, but force in different instances. So if we know that tension is force now. So irrespective of what the formula might be, we don't care. We can use the dimension of force as the dimension of tension, or the formula for force for tension. So, and then this is said to be mass per unit length. That is, the mu is mass per unit length. So what do? We are going to equate what we have in our left hand side to what we have in our right hand side. Remember, this v is velocity. So we are going to bring them down. Remember, when I was discussing dimension, I told you that the physical quantities we are going to use to determine dimension of other quantities are those three basic fundamental quantities. We said mass, whose dimension is m. We said length, whose dimension is capital L, and we also said time, whose dimension is capital T. So these three physical quantities is what we are going to be looking at while we are breaking down these other ones. So if we look at this, velocity is not here, tension is not here, and mass per unit length is not here. So we have to break this down until they represent these three physical quantities. So velocity, we know that the formula for velocity is displacement. Velocity is displacement all over time. Displacement over time is velocity. That is for this side, equal to, we can ignore this key for the meantime. After we are done, we will return it, but dimensionally we don't need the constant. So this is tension, and I said that tension is force, and you know that force is mass times acceleration. So we can use mass times acceleration raised to power x, and this one, the mu is mass per unit length. That is mass all over length. Mass over length raised to power y. So if we continue like that, dimension of displacement is L, because displacement is also a length. I told you, just like we have described under tension, displacement is length. It can be distance, it can be width, breadth, height. These all have the same dimension. So knowing that displacement is L divided by time is T equals, open bracket, dimension of mass here is m, but acceleration is not here. So we have to break down acceleration again, and we know that acceleration is velocity over time. Acceleration is velocity divided by time. So all raised to power x, remember. And then this other one, the dimension of mass is m, dimension of length is L raised to power y. We continue again. L over T is equal to, open bracket, m times velocity. Dimension of velocity is not known, so we can break down velocity again, which we know is displacement. Velocity is displacement all over time. Remember, velocity is displacement over time, and that velocity is over time again. So these two represent velocity divided by this time, that is this other time, raised to power x into m over L raised to power y. So we go down again to have L over T is equal to m times displacement is L, T over T will give us T squared, that is time squared, and you have this raised to power applied by m over L raised to power y. Remember, dimension is not written in fraction form, so we are going to write it in standard form, in index form. That is LT raised to power minus 1 is equal to MLT raised to power minus 2 raised to power x times ML raised to power minus 1 raised to power y. So we have here LT raised to power minus 1 is equal to, we open our bracket, m raised to power x, we write it m raised to power x, L raised to power x, we write it L raised to power x, T raised to power minus 2 times x, we have T raised to power minus 2x. And then this other one is m raised to power y. L raised to power minus 1 times y is minus y. So we put the collect like terms. We have LC raised to power minus 1 here is equal to mm. By indices, since the bases are the same, we add the powers. So we have m raised to power x plus y. LL here, since the bases are the same, we add the powers. We have L raised to power x minus y. And then t raised to power minus 2x. So if you look at the left hand side, we have just L and t. And at the right hand side, we have m, L, and t. So what we are going to do here is to make sure that both sides have the same number of quantities. These have m, L, t. So we are going to introduce m here. I can say m raised to power 0 here, L, and then raised to power 1, t raised to power minus 1. This m I have introduced here raised to power 0 did not change anything, because any number raised to power 0 is 1, and so it will return back to this. And L here is raised to power 1 is equal to m raised to power x plus y, L raised to power x minus y, and t raised to power minus 2x. So we compare the two quantities. We look at these and this. The m here and the m here will compare the power. So 0 here is equal to x plus y. So we are going to write it x plus y equals 0, equation 1. We compare L and L here. We have either x minus y equals 1, equation 2. And we compare t and t here. We have that minus 2x is equal to minus 1. And we have 3 equations. So these 3 equations will help us to solve simultaneously and get the values of x and y. So look at the equation 3, we have only x. So I can simply say divide by minus 2, divide by minus 2. This will cancel this, and minus will cancel minus, so that x is equal to 1 over 2. And if we substitute x 1 over 2 in any of the 2 equations here, I can say x plus y equal to 0. So I say 1 over 2 plus y equals 0. So y is what? When 1 over 2 crosses the equality sign, it will be minus 1 over 2. X is 1 over 2, y is 1 over 2. Remember, the equation that gave rise to that is v equals k t raised to power x and mu raised to power y. So having gotten x and y, we say that v is equal to k t raised to power x. Our x is 1 over 2 and our y is minus 1 over 2. Of course, by a lot of indices, we can say this is k t raised to power 1 over 2 all over mu raised to power 1 over 2. Because of this negative, we can bring it down to remove the negative, because in a lot of indices, if we move this thing up, it will become negative. So since it's negative, we can bring it down as well. So v is equal to k raised to power 1 over 2 raised to power 1 over 2 is the same as root. So we can say the square root of t all over the square root of mu. And these two things can be put together to give us v equals k square root of t over mu. So this becomes the relationship between v, t, and mu. So v is directly proportional to the square root of t and inversely proportional to mu. You see how we have been able to generate a formula using dimension. These 3 quantities, nobody told us the formula, but we are able to generate it using dimension. So this is what is required of us in this question. I hope you enjoyed the class. See you in our next video. Thank you.